All right, good afternoon, everyone, and welcome to our Walking Working Surfaces webinar. My name is Lauren Roberts. I'm the program specialist for the Atlanta MBDA Business and Advanced Manufacturing Centers at Georgia Tech. And on behalf of everybody at the Minority Business Development Agency, or MBDA, our MBDA centers, and Georgia Tech, I wanted to welcome you. We're excited to host you today and hope to answer any questions you may have about this topic. So before we begin, I wanted to give a brief overview of our agenda. I'm going to spend a few minutes just talking about our Atlanta MBDA centers and what it is we do. And after that, I will hand things over to Georgia Tech SHES, or the Safety, Health, and Environmental Services Program. Kenny Davis will speak, and then Dana Atkinson will speak, and afterwards we will have a Q&A discussion, which I will moderate. And then after that, I'm going to speak briefly about some upcoming events, and then we will finish. I wanted to take a moment to thank our sponsors. So firstly, thank you to the Minority Business Development Agency, which is our federal sponsor. And I also wanted to thank our center level sponsors, Comcast, EBCO, and Train Technologies, for supporting our vision. This is all possible because of their support. At this time, I would like to give you all a brief overview of who we are and what we do. So Georgia Tech operates two MBDA centers, the Atlanta MBDA Business Center and the Atlanta MBDA Advanced Manufacturing Center. Our mission at both centers is to help minority business enterprises, or MBEs, experience growth, create and retain jobs, and become sustainable, thereby having a positive economic impact on communities and the nation as a whole. We are part of a national network of 35 plus centers and special projects that are all focused specifically on growing and strengthening the minority business community in the United States. Our centers operate with a focus on access to capital, opportunities, job creation and retention, technology, manufacturing, and exporting, among other initiatives. MBDA is the only federal agency solely dedicated to the growth and global competitiveness of U.S. minority-owned businesses. MBDA recently celebrated 50 years of this commitment. I would like to take a brief moment to acknowledge our MBDA Center staff. As I mentioned, I am the program specialist for our centers. Donna Ennis is the founder and director of our centers. We also have working with us Anita Davis and Jennifer Pasley, who work with our clients as business advisors to bring them finance and access to capital. Aisha Jones, who is also on the line with us, is the event planner for our Enterprise Innovation Institute and has been a great help in putting this event series together. We also have Brandy Nagel on the line, who, along with Doreen Kincaid, is one of our part-time program coordinators. We also have Dr. Billy D. Brown, Anthony Jackson, and Jamarcus King, who serve as our manufacturing advisors. And last but not least, we have Towan Isom, who is the marketing director for our National MBE Manufacturers Summit. If you have any questions, feel free to reach out to our team or to me to learn more about MBDA, our center network, and how we can assist you. So finally, before we begin, I did want to speak a little about the CARES Act. In June, the Minority Business Development Agency received funding from the CARES Act to provide assistance to minority businesses. As a result, MBDA business centers around the country, including ours, receive funding to bring unique assistance and programming to not just minority businesses, but organizations and small businesses of all stripes. So we've launched our CARES Act Assistance Program in the past year with training and technical assistance in subjects like health and safety, cybersecurity, compliance to the Paycheck Protection Program, which has been a big event, and topic, funding identification and pivoting strategies. We're also continuing to conduct client pulse checks, and we'll conduct listening sessions and roundtables with small and minority-owned businesses to determine needs, challenges, and solutions that will ensure that all of our companies succeed post-COVID-19. And so at this time, I would like to turn things over to our Georgia Tech She's team.
Good afternoon, everyone. Thanks for coming. There's a couple of announcements I want to make really quick. First is I want to thank the MBDA team for inviting us to help them out with these seminars and to take part in the CARES Act, this CARES Act grant. Additionally, I wanted to tell you guys about what we do. We work with the Georgia Tech Safety and Health Consultation Program, where we offer small or free consultations to small and medium-sized companies throughout the state of Georgia, regardless of industry. You could be in construction, you could be in manufacturing, you could operate a doctor's office. So we would come out and do site inspections, review training and administrative programs required by OSHA, as well as do a survey of your overall safety and health management system. So those are just a couple of things that we do. And then Paul or Dana, if you could put a link to our website in the chat. If you have any questions about what we do or want more information on our program and the consultation, please visit our website and fill out the request form. So today we're going to be covering 29 CFR 1910, 21 through 30, which is the Walking Working Surfaces Standard, Subpart D of General Industry. Sorry about that, I was trying to forward my slides. Here's my contact information. As they mentioned before, my name's Kenny Davis, and here's my email if you guys have any questions. So Subpart D, it's broken down into several sections. So 21 covers the scope, application, and definitions of the standard or the subpart. General requirements is covered in 22. 23 covers ladders. 24 covers step bolts and manhole steps. 25 covers stairways. 26 is dock boards. 27 is scaffolds and rope descent systems. 28 is the duty to have fall protection. 29 is fall protection systems, criteria, and practices. 30 is training, and then 140 covers personal fall protection systems, which is mainly addressed in 28 and 29, but it breaks it down a little bit more specifically there. Some background. So here's a little bit of data for you all. Slip, trips, and falls account for the majority of all general industry accidents and cause 15% of all accidental deaths and are third only to violence and motor vehicles as a cause of workplace fatalities. OSHA standards for walking and working surfaces apply to all permanent places of employment. So housekeeping. All places of employment, passageways, storage rooms, and service rooms shall be kept clean, orderly, and in sanitary condition. So you want to make sure that all of your walking working surfaces are free of debris, equipment, tools, materials, things that could make employees slip, trip, or fall. Extension cords are a common occurrence in facilities. You know, you're running an extension cord clear across the plant to power maybe a portable hand grinder or something like that. We want to eliminate that and keep things out of those walking and working surfaces. The floor of each room is maintained in a clean and, to the extent feasible, a dry condition. So a lot of the facilities that we visit, it could be older buildings where you may have roof issues. So there's a lot of facilities that I've been to personally where there's been roof leaks. And so then you have puddles in various spots throughout the facility. Aside from, you know, the slip, strips, and fall hazard of coming in contact with a wet surface, you run into issues with potential issues with electrical sources. So water and electric don't mix. We all are pretty familiar with that, I'm sure. And also damage to product and equipment that we have at the facility. Housekeeping, whenever we have wet processes, then we want to make sure that we provide mats, false floors, and other similar controls to protect our employees from the slipping and falling. Slip-resistant shoes. These mats depicted in the right picture there, you see those a lot in the food industry, restaurant industry, a lot, especially whenever you're looking like at the dishwashing area. They have a lot of these types of mats. It lets the water go through the holes, but still provides a semi-dry flooring to be able to stand on. Walking working surfaces should be maintained free of hazards such as sharp or protruding objects, loose boards, corrosion, leaks, spills, snow, and ice. The last two, snow and ice, we don't encounter too often down here in Georgia, but it does occur occasionally. And then there's some, some of you might be on the call today from various parts throughout the U.S. where snow and ice are an issue for the majority of the time, could be up to 6 months a year, depending on where you're located. So we want to make sure that those areas are adequately treated. And then again, just inspecting the working surfaces to make sure that we don't have any additional hazards. It's the employer's responsibility to ensure that all walking working surfaces permitted for employee use are capable of supporting the weight of the employee, their tools, and any other machines or equipment that might be on that platform. Inspection, maintenance, and repair. Inspect your walking working surfaces routinely to ensure that they're adequately maintained in a safe condition. Any hazardous conditions identified during inspections or reported by employees should be corrected or repaired before the employees continue to use the surface. And then whenever you have any kind of defects or deficiencies with structural parts of the walking working surfaces, then those only can be repaired by qualified person. When we're talking about qualified person in regards to OSHA, they identify those persons as by degree or certificate or having the necessary knowledge, training, or experience on that subject matter. Ladders. So ladders are commonly used just about in every industry. We are starting to see the use of ladders go away and being substituted with things like scissor lifts or other mobile elevated work platforms where applicable. But when we are using them, we want to make sure that we're using them appropriately and for the use in which they are prescribed by the manufacturer. So all ladders are covered under this standard, with the exception of emergency ladders used in emergency operations such as firefighting, rescue, and tactical law enforcement, and any training operations related to those. And also any kind of ladders that are designed into part of the machine. So some equipment requires you to get up to a certain area on the piece of equipment to operate it or to perform servicing or maintenance or something like that on it. Those ladders would not be covered. So ladders that are a part of equipment are not covered by this standard. So common types of hazards that we come across with ladders are going to be ladder misuse, not using the right ladder for the job, whether the ladder's too short, whether you're using a portable A-frame ladder or step ladder as an extension ladder and leaning it up against the wall rather than using it as it's desired and opening it all the way up and making sure that the spreader bars are locked into place. Also, other issues that we see are going to be overreaching. So rather than getting down off the ladder and moving it to another area to safely access whatever we're dealing with, employees will overreach. And they're going to come back and say the same thing that they most oftenly say, you know, I was trying to save time. If I would have had to get down off the ladder and moved it, it would have taken more time. It would have taken more time for the job to get done, and so on. So here's some general requirements. We've already covered these. So ladders are used only for the purposes for which they were designed. Ladders must be inspected prior to initial use during each work shift, meaning that if you're using the ladder today, you need to inspect it before you use it. If you're not going to use the ladder at all today, there's no need for inspection. If any defects or deficiency are observed during the inspections or reported by employees, then the ladder should be tagged dangerous, do not use, and remove from service until those issues have been corrected, or you've thrown the ladder away and replaced it with another one. Each employee should face the ladder while climbing up or down, and should at least use one hand to grasp the ladder while climbing up and down. They also shouldn't carry any materials or equipment that could cause them to lose their balance while going up and down the ladder. So commonly when we talk about ladder usage, everybody talks about 3 points of contact. And while that is the best practice to maintain 3 points of contact, 2 feet and at least one hand going up the ladder, or vice versa, that is not a requirement by OSHA. And a lot of times people will say, you know, that's required by OSHA, but OSHA just requires that you use one hand and that you don't carry anything that would make you lose your balance. For extension ladders, we want to make sure that they extend at least 3 feet above the working surface at which you're trying to access. If you can't get that 3 feet extension above it, they do provide allow you to be able to secure it, or if you secure it in place at the top and bottom to prevent it from slipping out, then you're allowed to use it that way. As far as the slope, when we talk about the slope of the ladder being set up, it needs to be set up using a 4-to-1 ratio, meaning that if you have an 8-foot ladder set up, it needs to be at least 2 feet out at the bottom. So for every 4 feet of rise, you need to have 1 foot of run, or 1 foot of run rather. You should not tie or fasten ladders together unless they're designed or approved for that by the manufacturer. And you shouldn't be placing the ladders on boxes, barrels, or other unstable bases. So here again, this is another common issue that we see with ladder misuse, is that OSHA doesn't allow you to use the top step or the cap of ladders. So you're not allowed to use, if you're looking at this, the picture on the left here, the guy standing on that top step here, you're not allowed to do that. And you're not allowed to stand on the top cap there either. And sometimes, or a lot of times in construction anyway, this comes down to job planning. So planning out the works, and maybe this guy's installing a fire sprinkler system, but the HVAC guys have already came through and installed the ductwork, which requires him to work at a higher height and kind of maneuver his body around that equipment. So in this case, he needs a taller ladder or maybe a scissor lift. And then you have this, you see the same issue in both of the other pictures here on the right. It's hard to see in this picture, but it looks like, or what we're looking at here in the picture is that both of these ladders are actually tied together using ropes. So they're not, you know, that's not one unit, that's not one extension ladder. That's a ladder, it looks like an extension ladder and another ladder added on at the top of it. So some requirements for fixed ladders, and the diagrams are going to help us out the most on this one. So you're only allowed to have 30, so if we look at this picture on the right, you're only allowed to, you have to have at least 30 inches of clearance between, on the climbing side of the ladder, between the ladder and any other obstructions. If you do have obstructions, then you have to use deflector plates. And at that point, it can't reduce that space to less than 24 inches. On the back side, if you're looking at the back side of the ladder, opposite of the climbing side, there needs to be at least 7 inches between that wall and the ladder. If you're working in an elevator pit and using an elevator ladder, then you need to have, or elevator shaft rather, then you need to have at least 4.5 inches of clearance. Let's see here, 10 to 14 inches. So all of your rungs should be spaced minimum 10 inches apart, maximum 14 inches apart. And that just about sums it up for those. If you're using, you should never use fixed ladders that are pitch greater, that have a pitch greater than 90 degrees from the horizontal. And then if you have a hatch cover at the top of the ladder, then it must open with sufficient clearance to provide easy access and open at least 70 degrees from the horizontal if a hatch counterbalance is used. And then the step across distance between the ladder and platform should be between 7 and 12 inches. Fixed ladders more than 24 feet. So this is a new requirement that came out in November of 2018. And they basically say, so if you have an existing ladder, so installed before November 19th, 2018, then you have to have a ladder safety system, personal fall arrest system, cage, or well whenever you're on these types of ladders, using these types of ladders. For those ladders, if you have to have rest platforms at heights no greater than every 50 feet. So every 50 feet high you go, you should have a rest platform, and it should be 24 by 30 inches at minimum. And then those should also offset so that if you would fall to the lower platform rather than falling all the way down to the bottom. For new ladders installed, so ones installed after this date, so November 19th, 2018, they should be equipped with a personal fall arrest system or a ladder safety system. When a fixed ladder, cage, or well, or any portion of a section is replaced, personal fall arrest or ladder safety system should be installed in at least that section. If you have more than one section that you have to replace and you have to implement your ladder safety system device or your personal fall arrest system, then it has to be continuous at that point from the bottom of the ladder all the way to the top. It has to be used to protect the employees. On or after November 18th, 2036, all ladders, so even the old ones, the ones that fall under this existing category right now, will have to have a ladder safety system or personal fall arrest system. And then the ladders equipped with the personal fall arrest system or the ladder safety system have to have rest platforms at intervals no greater than 150 feet. So some criteria on ladder safety systems should allow employees to climb up and down using both hands, and doesn't require employee to continuously hold, push, or pull any part of the system. The connection between the carrier and lifeline and the point of attachment to the body harness does not exceed 9 inches. The design and installation of the mountings and cable guides does not reduce the design, strength of the ladder, and the requirements for the mounting strength. All right, now I'm going to pass it over to Dana, and he's going to cover the rest of the presentation.
Thank you, Kenny. And I got the ball there, so I'm now the presenter. Thanks again to everyone. I'd like to thank everyone the MBDA bringing us to be part of this roundtable. So let's see, is my clicker working?
Dana, you're on mute.
Wow. Okay, great. Let's try this again. Thank you for everyone in the MBA program for inviting us to come to this roundtable. Having an issue here with clicking the slide. I know I have the presentation ball, but it's not, my clicker's not working.
Dana, there you go.
Okay. Did I just do that? Okay, I see what's going on here. All right, so let me go back. It's going to, I'm sorry, it's going the wrong way. There we go. I'll use the buttons on this side. All right. Walking working surfaces. So in the walking working surface here, it always also talks about step bolts and manhole steps. This is usually a utility thing or a telecommunication aspect. I haven't said anything in this of the walking working surface standard. This was handled regionally. A lot of safety in the utility world is handled regionally. But it's pretty straightforward here in regards to the spacing, the steps. This is, of course, in a situation where you're not using any other kind of a powered lift, knuckle boom truck or whatever that the utilities often use to access said power lines. All right, steps. The OSHA magic number is the number 4. If we ask you for a number in OSHA, 40% of the time the answer is 4. Example here is if you have a stairway that has 4 or more risers, and that is the vertical member of the stairs going. If it has 4 or more risers, you're required to put in place or have in place already a handrail or a stair rail. So this is up to the architects that are designing our facilities and so forth and so on. If they drop the ball and we have a situation where we have a situation where we have 4 or more risers, you have to modify space with a handrail or a stair rail. Why I'm measuring risers instead of steps? Because there can be the semantics of that's not a step, that's a landing, so forth and so on. You do see some buildings where there's something that is broader than or deeper than a stair that is a landing, and in those instances there, they won't have a handrail. But in an atypical stair, atypically 9.5 deep, at least a certain width, so forth and so far. 4 risers, got to have a handrail or step rail to assist people climbing up and down those stairs. All right. So we talked about the vertical aspect of stairs. Now let's talk about the width aspect of stairs. Wherever these stairs service in regards to a occupancy in a work environment, thinking about a tall building, if you go all the way back to buildings were built pre-World War II, as in people in New York and the Northeast were referring to these as pre-World War II buildings. I'll give you the example of the Empire State Building. Empire State Building, the upper stories in the 80s and 90s, so forth and so on. The staircase area for egress would be approximately 42 inches wide. And then as it starts working its way down the building, the staircase would get wider and wider and wider. And that is because the idea of as people enter the staircase, the occupancy number for that staircase as you work your way down the building gets greater occupancy number, you need greater width to have space for those people to evacuate safely. This is the idea here of the stair width of the staircase, at least 44 inches being one cut on like one handrail. Greater than 44 inches, you could have a handrail and a stair rail, maybe on a wall or something, an aspect there, or one handrail in the middle, so forth and so on until it goes all the way to 88 inches or greater. So here's a very narrow staircase that we're seeing here. This staircase, the magic number or the idea behind a staircase like this is if this staircase is just leading to a storage area, it can be 22 inches wide. If this staircase is part of an egress route, i.e. what that means is the staircase leads to someone's permanent place of employment, permanent place of work or their office, and they would have to evacuate from that area quickly, then the width of the staircase would have to increase 6 inches to 28 inches. Where does this come from? This comes from the NFPA 101 Life Safety Code, which OSHA incorporates by reference into the regulations. Who's going to have an issue with this? Initially OSHA would be, but more closer to the vest would be the idea of a fire marshal coming in and inspecting your facility and inspecting areas that service someone's working area. If they're serviced by stairs, those stairs, because of the egress consideration, need to be at minimum 28 inches wide. And even at 28 inches wide, that's a pretty narrow staircase. So talking more about staircases, I call this the job trailer rule. What we're talking about here is staircases that lead to a door, a stairwell, or if there are site-built stairs that lead to a door to a job trailer or something like that. But there has to be a platform or a landing, like I mentioned previously, that is greater than the door swing or the width of the door by at least 22 inches. Let's do the inverse here and say if there was not a landing there. Imagine climbing a set of stairs, getting to the top stair, grabbing the doorknob for said door, and then having to climb back down 2 stairs to swing the door open and then climb back up the stairs it goes through. It's just intrinsically not safe. So in this aspect here, originally it was 20 inches for some particular reason. Now, OSHA had updated it in January 2017 to add 2 more inches. So you have the width of the door plus 22 inches in regards to linear length of said platform. Or landing, excuse me, let me use the right terminology both times, landing. Let's talk about dock boards. And these dock boards here are basically, if you have a loading dock, you need to have some kind of methodology of making level the transition from the loading dock to the back of a truck or box truck or semi truck, whatever the aspect is. Some loading docks, it's already level. Some loading docks, there's a slight differentiation due to the suspension height of the truck that's coming in. These loading docks or dock boards you see in the picture are for when you're moving materials from loading dock to the back of the truck or vice versa by powered industrial truck, forklifts, so forth and so on. They have no handrails. If you have loading docks that are required for people that are walking and carrying materials, then you'll see, like in the next slide here, you'll have handrails. Oh, this is the wrong person. I'm sorry. You'll see dock boards that have handrails on the side. The idea of the dock boards or the handrails on the side is you have a person who's walking on a working surface, and if there is a fall potential to the left or to the right of said loading dock connection point between truck and loading dock, that handrail serves that purpose passively. The idea here with the handrails is that if someone's in a powered industrial truck, they're wearing a seatbelt. If they have a seatbelt, that seatbelt addresses that passive necessity for fall protection in that situation. So scaffolding, I really do like this picture on the left here as a trainer. As a trainer, if we saw this in person, we would be very upset, but it's great for us as a picture because the statement about this picture is always, everyone in this picture is fired. They're doing absolutely positively everything that you could do wrong with scaffolding in one great picture. Short of, if I had a greater picture of everything, the other aspect I would have is how is this scaffolding supported on the ground? Does it have proper base in regards to the feet of the scaffolding to make the scaffolding stable, excuse me. What's going wrong in this picture? Why am I firing these people? Well, first of all, you cannot use an external ladder to access a scaffolding. You can see in the drawing on the right there, this is a more involved scaffolding setup here where we have internal stairs. The access of the scaffolding, like you see in the bottom right-hand picture here, or a stair bait system in here, has to be intrinsic to the scaffolding itself. You cannot use an external ladder to access scaffolding. Looking at the scaffolding on the mobile here, you'll see that mobile platform that is on the top aspect there is fully boarded out, as we say, or fully cleated out with a board. That is not the case here in the picture. They're even on the wrong stanchion there. A guy's kneeling on it. There's board areas that's missing. There's a cross brace that is evident on the back side of the scaffolding, or the scaffolding part closest to us, that's not evident on the other side of the scaffolding. Cross bracing in some instances is part of the handrail system of scaffolding. You can use it as either a mid-rail or a handrail, but not both. And then the other aspect here that you see in the pictures for both scaffolding examples that are diametrically opposed in the drawings on the side, we have a toe board. Because if you're 8 feet in the air and you have a piece of material that is happening on the scaffolding, one of the hazards you need to address is the fact take off, knock off. The issue is falling off the scaffolding, hitting someone below. The other scaffoldings we see here, the platform scaffold there with the 2 ladders, and the mobile scaffold, or I call it the window washer scaffolding we see on the left-hand side, using a cantilever support system, are all covered in the OSHA regulations as well. All right. So the fall protection is for scaffolding greater than 10 feet. All scaffolding starts at 10 feet. There has to be some kind of fall protection system in place, and 99 times out of 100, it'll be a passive system with handrails or plastic sheathing or whatever the aspect is there to protect not only people from falling, but equipment and materials falling off said scaffolding. 4 times the maximum intended load, must be 18 inches wide for the narrow scaffolding you'll see out there sometimes. And supporting scaffolding must be restrained at a 4-to-1 ratio of its height as it starts working its way up in the air it needs to be tied off at certain points, at minimum points of 4 to 1, to the structure that it's serving as scaffolding. Let's see. Safe access, which talks about a ladder. All components must be present. Never climb the bracing. Once again, that is safe access using an intended ladder that's intrinsic into the scaffolding. The other part here is one of the dangers of scaffolding is where you set it up and its proximity to power lines. The magic number in regards to the proximity of anything, be it a ladder or scaffolding, to any energized power lines is the number 10. No feet from any power lines. 3 feet from insulated lines. How do we know they're insulated? Not unless you're working in the utilities or realm or ET&D, electrical transmission and distribution. I'm not going to depend on any visual inspection of insulation unless I have utility people in place and give me that validation. Fall protection. Once again, the OSHA magic number, 4 feet. If I have vertical change of greater than 4 feet in general industry, I must provide some kind of fall protection. For anybody out there in the world that's in the construction world, you guys get a little more leeway. Your magic number, at least in fall protection, is a 6. There's too much going in construction to say there is one magic number, but I'll just say in regards to fall protection, the magic in general industry is 4, and the number of construction is 6. 6 feet or more in construction provide some kind of fall protection. 4 feet or more in general industry must provide some kind of fall protection. Guardrail systems are a form of fall protection. They are a passive fall protection system that exists. The specifications of a properly built handrail is the top handrail, the top rail of the handrail system needs to be 42 inches plus or minus 3. So that means it can be up to 45 or down to 39. Mid-rail, split the difference. And then this guardrail system that exists must be able to handle 200 feet of force on the top side there, both down and out. How do we determine 200 pounds of force? We don't go find somebody who weighs about 200 pounds. What we do is we realize how the guardrail system is built in structural. It's built the right way. It will hold way more than 200 pounds in its aspect. So we meet this specification for support in the way that the guardrail system is built and designed and the connection methodology. All right. If I have a cover covering a hole, that integrity, structural integrity of the cover should be at least twice the intended maximum load that can be imposed. Basically, you want to over-engineer any cover that's existing over any kind of in the construction world. Because we don't know what the intended load could possibly be, what sometimes we do is we build a cover over an opening and we make the cover slightly proud of the floor surface with 2x4, so forth and so on, the plywood will be used. And that way, people have to avoid putting loads on the wall on that opening in the first place by going around it in one way or another. All right, so automotive repair pits. There's no really feasible way to protect these passively from a fall aspect there. So what happens here is we create these areas where we have these pits as authorized personnel only locations. Copious signage, tapage, that's not a word, tape, visual clues, whatever the aspect is, to tell people that, look, there is a hazard here, keep your distance in one way or another, and the magic number for that is 6 feet in regards to distance from said pits or openings. There it is, a visual representation of a properly built out scaffolding. And in that scaffolding there, we can see metal tubing with proper connection points that will hold 200 pounds all day long, with a top rail, mid rail, and then you can see a pretty extensive metal plate toe board. This toe board needs to be at least 3.5 inches in height and should be able to sustain 50 pounds in force in a lateral force on said toe board. Where does 3.5 inches come from? Nominal height of a 2x4. Once again, we're borrowing the specification of scaffolding from construction, where they often build these platforms and working surfaces and scaffolding out of wood members, nominal lumber sizes. All right, so as we can see here, there's a loading dock here with a guardrail system in place that is put in the proper orientation of the 2x4 to meet that 200 pounds in force in both a lateral and downward direction. You can see how that's connected there, and these seems to be readily removable guardrails for an opening for loading materials. So you can have that as well, just as long as it's pleated properly and it is stable and can hold 200 pounds in its proper orientation. Nets. Nets for fall protection. Nets for fall protection are for things, not people. The onus that's placed on someone that's going to use nets for fall protection is quite it's very discouraging. The use of nets for fall protection will require daily testing with a 200-pound dummy, and you can use the nets at a spacing of at no more than 30 feet from the point of where you're trying to protect from a fall. It's just not feasible to use nets for people in regards to fall protection nowadays with the technology that we have. What you're seeing here in the position here is people who are tied off in a fall protection system with what's referred to as positioning systems on their waist, on the waist belt of their harness system. What is going on here is we have two construction workers that are tied off, and they're tying up formwork, concrete formwork in the aspect there, and their one connection point that's above their head allows them to have a scrub area that's quite wide. As they work that scrub area quite wide, they could get to the point where they are very lateral of their connection point for fall protection, and maybe elevated a little bit closer to their fall protection than they would be usually at a 6-foot lanyard length. If they slip and fall while they're on this matrix of formwork, they could do what's referred to as a pendulum effect. And that could be a hazard in itself. So what happens here in this situation here, where you're scrubbing in a large area, like tying in formwork, you can use, or you're required to use, a fall protection latch to keep you from elevation from falling, but also positioning systems to keep you in place while your hands are free to do the work you need to do. This is the roofer guys. This is the roofing system, or the access system that's allowed both in general industry and construction in regards to access to a roof. The magic number here is 6 feet. If you have someone who's doing work that is infrequent and temporary on a roof in general industry, and the work does not require them to break the 6 feet zone to said roof, then you do not need to provide any fall protection. You do need to delineate that 6-foot line area and tell them and demonstrate to them and train them that they cannot break that gap. Look in this picture here, you see a parapet wall on the right-hand side. If parapet wall that goes around the entire structure of your roof structure, the entire perimeter is at least 39 inches high, then what you have is an intrinsically already built-in handrail system for your roof, and fall protection is not required. So we borrowed the fall protection standard from construction in general industry. For folks that are not familiar here in the OSHA world, there are two main sets of standards in regards to safety. 1910 is general industry, and 1926 is construction. 1926 is based on 1910 with a bunch of variances added in because of the dynamic nature of the work in construction. For the longest time, fall protection was considered only a construction problem, but as we've realized and looked at the data, we realized protection is also an issue in the general industry world. So what we did was, in updating the walking working surface standard, they carried over the fall protection system codification from construction right into general industry. So now we're talking about anchor systems, fall protection system, fall arrest systems, and positioning systems in the same way we did in construction as we do in general industry. Designated areas, that is the aspect that we just talked about on the roof, the per 6 feet. That carnival tape you saw in the previous picture there is not carnival tape. It is a warning line system with a minimum breaking strength of 200 pounds. It does not mean it can hold 200 pounds. It means just if it was impinged upon with 200 pounds of force at one point, it would not break. Training requirements. You must train people on the use of fall protection systems, the understanding of fall hazards. And one of the things that is the onus of doing fall protection training is you have to understand the OSHA regulations, and then you have to understand what type of equipment you're going to use to meet the standards that OSHA requires. These are often proprietary systems of fall protection equipment, MSA, whatever those companies are that are out there that do that kind of stuff. The training must be understandable, and of course, anytime you find somebody who is not tied off, not wearing the harness properly, any of those aspects here where they are not properly using the PPE, the onus is that you have to retrain. You have to retrain these people in that aspect. So on our OSHA.gov website, this is one of the pages we have here that gives you some information on walking working services in regards to our on-site consultation program, a compliance form to file a complaint, or the information on the OSHA.gov website itself on the workers page for assistance with fall protection. So I've been talking quite a bit there. Let's open the floor up for questions. I can see Matthews. You have a question standing there. If you can go ahead, we can open Steve's mic and or put it in the chat there. We can start answering questions for the attendees.
Before we do, actually, just as a reminder for those who haven't attended one of these webinars before, so there's two ways you can submit a question. One is you can raise your hand, and then we can mute your mic, and then two is submitting your question into the Q&A box. But with that being said, it does look like Stephen has a question. So, Stephen, can you hear?
Stephen, you can go ahead with your question.
Stephen we're not able to hear you for whatever reason, but you can also put your question in the Q&A box and I can read it off to the panel. Does anybody else? Oh, hold on a second. Got a question from Woody. Provide an example of a ladder safety system.
Okay. Kenny, you want to get that? You want me to get that?
So do you want me to like pull up a picture or?
I can explain a little bit about the ladder safety system if you want me to, Kenny.
Okay, yeah, go ahead.
Okay, so where the ladder safety system material came from was the telecommunication guys and the wind turbine guys. These guys are going 100, 200 feet in the air, and the cage system just doesn't seem to work for them. So what they have as a ladder safety system is a harness, and then where you would have the positioning system in the front, there's a connection point that you connect onto either a cable or a rail that runs the full length of said ladder going up and down. And with climbing terminology, it's kind of like a prusset system. What it allows you to do is free climb going up with a connection onto that cable system that's connected to the said climber. But if the person slips and falls, that connection point will tighten down on that cable or that rail to keep the person from falling. Now, between the person when it's about 9 inches, so the acceleration due to gravity at a 9-inch fall is very, very minimal. So the strength of the system is way over what's actually needed, but that's what a ladder safety system is comprised of: harness, connection point on the front, and some kind of system either intrinsically to the ladder or to the periphery of the ladder, the right or left. When the person connects in, climbs up, free climb, and fall, it will connect. There is a switch on these systems there will allow you to free climb down, but as that system is kicked in, as you free climb down, if there is any acceleration greater than a certain number from falling, it will also grab onto the cable and do it again. We might have some pictures somewhere, Kenny, but that's a pretty much basic description of a ladder safety system. Let me know if that works for you, Woody. All right, good deal.
It looks like we had a question from Mr. Matthew about how to conduct training for 250 employees and still do it in safe conditions regarding COVID-19. So this can be done. You may want to there's different ways breaking up the training into smaller groups, so several small groups. Depending on your facility, how big of an area you can spread people out in, so they're at least 6 feet apart, and preferably wearing a mask or respirator. Also, if you have an outside area outside of your facility, that's a great way to you have better ventilation out there. You can spread out a little bit farther out there. And so those are all suggestions that I would have when it comes to training. Do you have anything, Dana, to add?
No, it really is pretty basic here. You know, we just have to keep each other out of our breathing zone per se. And if we can block off the breathing zone with a mask. So the aspect there, once again, 6 feet, that magic number keeps popping up. And then the idea of you wearing a mask and keeping people in a well-ventilated area. That's about I can't improve on that, Kenny.
Do we have any other questions? Feel free to put them in the chat or to speak up.
Let's see. Is there a distance? I have in the QA box. Is there a distance to edge requirement for guardrail or a lifeline, or I'm not sure what a permaline is. So guardrail, distance to edge requirement for guardrail. Guardrail would be right on the edge. Lifeline, if I'm interpreting this right here, on the roof is 6 feet. From wherever the person's working, it has to be a line that'll have 6 feet to said roof. This is the dynamic. This is based on the dynamic edge standard, dynamic roof edge standard from construction. There is also an additional one aspect there. If someone's doing something that is not infrequent or temporary work, they're working at an extended period of time on a roof, then that number bumps from 6 feet to 15 feet, and that's for personnel. There's also another addendum for equipment. If you have equipment on the roof, in regards to linear, if the equipment is moving this way, the delineation on each side is 15 feet, and then laterally, the delineation for that material moving in that linear line is 6 feet in that aspect there. I know I threw a lot at you there. Was that clear, or did I muddle the water? Let me scroll. It's clear. Okay, great. Thank you, Woody. I know it's hard to do this without visual aids here, but that's basically it there with the guardrail and the handrail on the left line.
Does anybody else have any questions? Bradley, no,
Bradley, no.
has his hand raised.
Mm-hmm. Let's see.
You should be able to take Bradley off of mute.
Hey, Dana, Brad again. Good to see
Hey,
you.
Brad, what's going on, man?
Hey, I'm doing well, thank you. Hey, kind of circling back to the question I had when we went to 511 with you, or 501 with you, whatever it was, 511. The scissor lifts. I cover a building in Miami and kind of got into a roundabout with a guy who says he didn't need to wear fall protection while on a scissor lift, and I said we kind of covered this in our class, but his building facility safety, his building engineer swears he must wear fall protection on a scissor lift. By default, they're off the ground 4 feet, which OSHA, that's the whole, cat and mouse with that number. But when they're in the air, what is the deal with this? So, I mean, I have told them that Paul and I talked about this. You and I talked about this. This is one of those gray areas. Like, I want to fight a chance. If this thing falls over, I kind of want to do the Tarzan thing and maybe catch a rafter or something versus being tied to this thing as it's over. So, yeah, no, you don't want to do the Tarzan thing. You do not want to be thrown clear. There's enough case studies out there. Yes, sir. People, and knuckle boom trucks and boom lifts that thrown clear. Superman is not going to work. So here's the deal. With a boom lift, with a scissor lift, with a aspect there, the
basic premise of fall protection is there's a handrail.
Yeah.
So boom, we got fall, we're good. We're now you're talking about when things go wrong. Okay.
Yes.
OSHA handrail. They can't ask for any more than that. But the deal is, if you look at any of the scissor lifts we deal with, or any of the boom lifts you look out in the world, they got tie-off points in there, don't
Yes,
they?
yeah. There's anchor points there for
Exactly.
a harness.
Exactly.
So, and a tether.
Yeah. So what is what it is? The manufacturer put that in there for a reason. And I'm sure if you look in the operations manual of said scissor lift, of said boom lift, they will say, while you're in the boom lift or the scissor lift, you have to tie off.
Okay.
So your guy that says I don't have to be tied off in here, he's basing it just on what OSHA says. He's kind of right, but in the all aspect, he would be not tied off. He's not operating the equipment properly. And
Sure.
he's in violation of that aspect there.
There's
And,
that
you know,
gray area. So yeah, and he was kind of
yeah.
a little bit.
You know,
Dana, can I weigh in on this one?
absolutely, Paul, jump in.
Hey, Brad, how you doing? Good to see you
good.
again.
Good to see
I'm
you,
gonna
sir. Thank you.
Keep my video off just in case my internet goes haywire. But anyway, my name is Paul Schlumper. I work with Kenny and Dana with the consultation program and the. But you know, it's if you look on the OSHA website, Dana, you can find, excuse me, not Dana, Brad, you can find some interpretive letters on this issue. And here's the thing, you know, if you're in a straight up and down scissor lift, right?
Yes,
Straight
sir.
down, no boom truck, no cherry picker. The assumption from an OSHA standpoint is your feet are on the ground and you're protected by railings, standard railings, top rail, mid rail, toe boards if necessary.
Yes, sir.
You know, in that case, from an OSHA perspective, you're not required to tie off. You know, if you feel better having people tie off, there is a tie off in some of these devices. If your policy is to have them tie off, that is certainly your prerogative. But from an OSHA standpoint, and interpretive letters will back me up on this, you're not required to tie off. Now, the ball game changes when you're in a cherry picker or a boom truck. Those folks need to tie off because now you've got that, you know, cantilever effect where the moment you just hoist them right out of the thing. So those people definitely need to be tied off. And again, I'm speaking from an OSHA perspective.
Right.
Yes, sir. Okay.
And
Awesome.
then the thing, and Paul, we've all seen this too. There's that human nature aspect of stepping on that mid rail, and then that's where a lot of people start adding in that aspect.
You bet.
Yeah, exactly. Yeah, a tether of sorts. Exactly. So it goes from there. So Brad, I think we've come at it at a number of different angles here.
Yes, sir. Okay.
We'll always get that. Always get pushback. You just have to push back. I just have to base it on context and let it.
So I'd like
Okay,
to
cool.
can I add something to it really quick as well? So I had a conversation the other day with Philip Greason. Well, actually, he was just teaching one of the classes, but the way he talked about it was you look at it from a risk assessment point of view. So looking at your probability and likelihood. So if you fall out of the lift, you're definitely going to hit the ground if you're not tied off. If you fall out of the lift and you're tied off, you know, is it going to pull the lift over? You got to look, you got to weigh, is it
Right.
going, so.
Yeah, and I think his thinking was that, you know, he's actually a tall guy. He's like 6'4", 6'5", and his center of gravity was a little bit over the rail. So that was his thinking of like, okay, if dude falls out, I mean, you know, give the guy a fighting chance, not the Tarzan thing.
All right.
Okay, cool. Thank you guys so much.
Yep.
You're welcome.
Before we take any more questions, I did want to point out, just because I've waited until the end of events or after Q&A to do this, and it's not as effective. We do have a roundtable as part of our roundtable consultation series going on this Friday, March 5th from 10 to 11. It's on hazardous material safety. I put the link to register in the chat and just wanted to let everybody know, because in the past when I put the links in the chat, then we just finish up and nobody has the chance to click on it or register. So with that being said, I wanted to go back to questions. Does anybody else have any questions? It looks like Woody might have a question.
Let me
I see a
check.
little question mark for the Q&A. Okay, no, never mind. That was about the distance to edge requirement.
Okay. You can give me that go away.
Anybody else have any questions?
I have a question. It might not be, you might have covered this already. It's Aisha. So you know, I do Christmas trees during the holidays and office decorations and all that good stuff. And
Uh-oh.
did you guys cover, I'm always on a ladder, but did you guys say anything about like when I always get worried that I'm on a ladder and I might fall, knock on wood, and then there's no one there. Like, is it like really a great idea to, when you're using a ladder, to have someone else there with you? Like in case of something like that? Did you guys cover that already?
We didn't cover that, and I can speak to this, Dana, then you can follow in if you want to, but having a spotter is always a good idea, not only to account for, you know, if you do fall off the ladder, but anybody else entering the workplace that might not know the ladder's there to bump it and maybe knock you off, especially if you're talking about work in doorways or passageways where the door might bump the ladder, or if there's any lit equipment operating in the area, talking about like forklifts and different equipment like that, it could maybe bump it. In those situations, you definitely want to have a spotter and even provide some like warning barriers, such as like cones or caution tape or things of that nature.
So I actually wanted to kind of piggyback with a similar question, which is like, you know, there's a difference, at least in my mind, between a step ladder and a ladder. Like a ladder's leaning against the side of a building. A step ladder is like shaped like a V. It's self-supporting. Does OSHA like have differing safety recommendations or requirements based on if you're using a ladder or a step ladder?
All right, so I can jump in on that one there. So the step ladder aspect there, minimum height, like 3-4 feet going in the air there. The OSHA doesn't really talk about what you need to do in that aspect there. I will say this though, anytime you're using any type of ladder, either an A-frame ladder or a straight stick ladder, and Alicia, I'm going to add on to that straight stick. I'm assuming with your Christmas lights, you're using a straight ladder that's leaned up against the house. Any type of ladder, I use something that's referred to as the belt buckle rule. Your belt buckle or your center of gravity should be between the rails at all times. So we shouldn't be doing stuff like grabbing on the handrail and then going way out here. Don't do that. Don't do that. Stay between the rails is one aspect there.
I pretty much use the ladder like an old lady, so no worries on that.
You're not okay. Well, all right. Yeah, there you go. Well, there are lots of construction people and firemen out there that will do all kinds of wonderful things with ladders. Even if you've ever seen someone who installs gutters, the dreaded ladder hop. You've seen people do. Let's not talk about that. That's not good. Okay, but maintain your center of gravity between the rails at all times. And then the climbing angle, which Kenny covered, that 4-to-1, it can also be done by your feet at the base of the ladder and your arms straight out. And due to your size of body and arm of your legs and your height, it should get you at about a 70-degree climbing angle, which is just about right for not pushing on the ladder too much, not pulling on the ladder too much, being pretty stable on that ladder. The other thing aspect there of the spotter, there's a spotter aspect, but then there's also the idea of the feet of the ladder. And most straight ladders, straight ladders you have out there will have feet that are on these kind of like rockers. When it's flat, you have that rubber connection, and that is for if you're on a concrete surface or a hard porous surface. The flip side is you often see sometimes those feet will rock back and you see these little teeth on there. And that's if you're out there in soft area, gravel, dirt, whatever, and you want to dig that ladder into the ground as a good anchor point and goes from there. So the combination of a good anchor point, a connection point with the feet or the teeth per se on that rotation part, and a proper climbing angle, and keeping your belt buckle between the rails at all times, climbing the ladder like an old lady, like you said, you should be, knock on wood, safe. Ladders can be misused all the time, but you should be safe if you take those things into consideration. Kenny?
You covered it perfectly.
All right, thank you so very much. There we go. I appreciate it.
I'm always like, because usually I do like the Christmas stuff in the office, like on a weekend when no one's around. And I'm always like, oh my God, what if I fall and I'm like bleeding out all week long before someone comes into the office?
How long have you been there? Yeah, that's the first question. Yeah, how long have you been there? Are you okay? Yes, yes. Terrible office stories. These things happen.
All right, so anybody else have any other questions? I'm just going to give it a few more minutes as a reminder for those who are interested in the roundtable on Friday. Link to register is in the chat. Dana has also put the Georgia Tech She's link in the chat. So I would just take a couple of moments if you don't have that on hand already to copy and paste it somewhere so you can go visit. If I'll just like wait a couple more seconds, but if nobody else has any other questions, we can start wrapping up. I see that Brad has his hand raised. I'm not sure if it's because he's had another question or he just didn't unraise his hand. Brad, do you have any more questions? I just want to make sure. Okay, never mind. No more questions. All right. All right. Well, at this time, we don't seem to have any more questions. If it's all right with you all, Dana and Kenny and everyone, I'll just go ahead and begin wrapping up because I think we're kind of ending close to on time anyway. So, all right. Well, like I mentioned, we are having our next roundtable consultation on Friday on hazardous material safety. Link to register is in the chat, along with OSHA's link or the Georgia Tech She's link. For those who want to sign up for a consultation, because they do offer free consultations for small to medium-sized businesses. And that's it. In the past we've had like at least a couple pages of upcoming events, but I think at least for the moment we're kind of winding down for March. So thanks for joining us.
Lauren, don't forget to mention the record keeping event.
Right, actually, good point. Okay, so my apologies. We do actually have some more events with Georgia Tech She's coming up on March 18th at 1 o'clock. We have scheduled an OSHA record keeping roundtable. I know the She's team offers full day trainings on OSHA record keeping. This will be kind of a high level overview of the basics. And we will have registration available for that shortly. But if you, again, thanks to everyone for joining us. Thanks to Kenny and Dana and Paul for their presentation. And if you want to learn more about our MBDA business centers, you can go to our website or you can reach out to me directly. But at this time, I just want to say thanks for joining us and thank you for your attention and your participation.